So I'm going to present probably a lot of data. Feel free to interrupt at any point if there's anything you'd like any clarification for. But yeah, so I'll get into it. So what I'll really be talking about today is this meta-rotation task in VR. So in case you're not familiar, meta-rotation is this kind of ability for us to manipulate objects within our own minds. And so if you, for example, have like a phone or something like that, you can close your eyes and you can still picture that phone. And furthermore, you can also manipulate that phone when you close your eyes, when you have that in kind of your, as a part of kind of mental imagery. And so there's kind of for the last 50 years, people have been fascinated by mental rotation. There have been thousands and thousands of studies on all sorts of different topics related to mental rotation. And for example, one big topic has been sex differences. And so that would be what I'll be presenting on today. And so part of the interest in the sex differences on mental rotation tasks, like part of the interest comes from the fact that it's actually the largest observed like cognitive difference between men and women. So if you test men and women on all sorts of different cognitive abilities, there's very, very little difference. It's very hard to find cognitive differences between men and women, but mental rotation seems to be one that is quite robust. It's found throughout all sorts of different studies, and it's, like I said, quite a large effect. But there's also these kind of questions about like, well, you know, what is this mental rotation, like how much does it really impact our everyday lives? What I've included here is like a classic like Shepard and Metzler task. So most of the time when mental rotation is assessed, they use this pen and paper test where you'll be given a key and you have to choose from several different options, either one or two that matches the key. And so a lot of people say, you know, how much does this really, this one question here, for example, how much does that really capture of kind of everyday life and mental rotation in everyday life? And so there's often a lot of debate about how much of the influence is genetic or how much of it is environmental factors. And so there's kind of this like desire for trying to make mental rotation more real world. And one of the cool things about VR is that as emerging technology, it's kind of giving us access to test these kind of questions in a new way by making it more real world. So,
going to give us the answer?
I'll get into it.
Let's do a hands up and see if the sex differences are real.
Just like put up your left hand and see who gets it wrong. So there's been one other VR study that tried to answer this exact question about if you put these kind of shapes into a 3D environment, how do people respond? And so this was a paper from 15 years ago, and it was actually using an immersive desk, like a VR system from going back into the 90s. So as you can imagine, the VR they used quite different than the VR of today. And so one thing that was also really interesting about this paper was like, unlike the pen and paper versions, they didn't find any sex differences. And so there's also kind of a lot of questions around why didn't they find these sex differences? What does that imply for mental rotation? Is that like an artifact of how they're testing it, etc.? So I'll show you what our mental rotation experiment in VR looks like. So here's a GIF demonstrating kind of what people would be seeing and how they'd be answering. So as you can see, they'd be selecting two shapes to match the key for each trial. So there'd be 20 trials. And as you can see, we base the shapes off validated tests, so the updated Shepard and Metzler task. So you can see here that the key matches the key, one matches one, two matches two. Another kind of important thing of note is that on this screen, you can't really tell that the objects are 3D, but in VR, it's quite obvious these shapes are both huge and 3D. Yeah. So I'll get into some of the data. So we found a huge sex difference. So slightly larger even than what's usually found on pen and paper. So we had 46 participants. On the y-axis here is percentage correct, and female and male is plotted on the x. So another way to just visualize that is just looking at each participant and looking at the percentage correct, you can see that there is this kind of separation of distributions between men and women. And so it's interesting that we found this effect, but again, we're kind of inherently skeptical about this effect and how real world this effect is and like what this really matters. And so kind of the more important part actually is trying to understand why we say might have found this effect in the study. And so at the end of the experiment, there was also a survey where they filled out a bunch of questions, and those questions were related to factors that other research in mental rotation has pointed out is playing a role in some of the observed sex differences. So one of them is arts and science orientation. So at the end of the experiment, they were asked about their arts or science orientation because there is this evidence that sometimes people that are more scientifically orientated or more interested in STEM fields tend to do a bit better on mental rotation. And so to make sure that there wasn't a bias in selection between men and women, that there was kind of an equal number of arts and sciences oriented people in both groups.
So were these all psychology students? Or?
So these were also all psychology students, which is an important note too, because that could also definitely be what's going on here. But to quickly finish off the arts and science orientation, as you can see, there's no difference between people that were orientated more towards arts or orientated more towards the sciences. So we could kind of quickly cross that off the list of being responsible. But kind of along this idea of the fact that they're all psychology students, one thing that I was worried about is stereotype threat. So for people that aren't familiar with stereotype threat is an effect where if people are aware of either a negative or positive stereotype, they can either consciously or unconsciously shift their behavior to conform to that stereotype. So an example, say with math is, for example, if boys are told that they're better at math than girls, and then you test them, the girls would do disproportionately worse and the boys would do disproportionately better. Same as if you tell girls that they're much better at language processing and abilities compared to boys, they will outperform boys, and the difference between them will get larger. So one of these questions I wanted to ask about was, well, because they're in psychology, there's a good chance that they actually would have learned about mental rotation, they would have learned about the fact that there are sex differences, and so I was kind of worried that these kind of stereotypes would be exaggerating this effect. So this is why I wanted to ask about stereotype threat. So at the end of the experiment, again, I asked them, were you aware that there's any chance that your gender or sex could be playing a role in how well you performed? And so plotted here are just the people that said, yes, I think my gender or sex could be playing a role versus no, I don't think so. So in a way, it was getting at how knowledgeable people were about these stereotypes in order to see whether that was influencing the results. And so if the stereotype threat effect was real, then what we would expect to see is that women that were aware of the negative stereotypes about them performing less well, they'd actually do worse. They'd conform more to that stereotype, but we'd find the opposite. So women that were aware of the fact actually tended to do better, and same with men, although only for men was it statistically significant. So again, this might have been kind of some other factor going on. So perhaps people that were more knowledgeable tended to do a bit better, and they also tended to be a bit more likely to be aware of the stereotype threat.
Would you say the
46. So there's 23 men and 23 women. So yeah. So it doesn't, again, seem to be like stereotype threat is explaining much of the effect. So one kind of key difference between this mental rotation task in VR compared to the pen and paper one is typically the pen and paper one is timed. And so part of the reason why that's really important is because there's actually this really interesting evidence to show that there isn't really an ability difference between men and women, but there's actually a metacognitive difference between men and women in that men are less likely to spend as much time double checking their answers, whereas women are more likely to spend more time double checking their answers. And so if you time people and you lose points for omitting answers, then the better strategy is to be basically more risky and double check your answers less because you'll tend to get more points in the end. And so what happens is on a mental rotation task, typically when you time it, the gender differences actually are exaggerated. And so one thing that was kind of just interesting off the bat was that in this experiment, it wasn't timed, but we still found those huge gender differences. But still kind of wanted to look at time to see whether that was influencing it. So there was no difference in overall time. However, there was a correlation between how long it took to complete it and how well they did. So I should have got to put a regression line in, but there is a small correlation between how well they did. So this is again percentage correct. And this is just the total length of time it took to complete the task in seconds. So like 900 seconds would be 15 minutes. One thing that's also interesting is that people did much better on the VR version of the task than the pen and paper version. So even if it was timed, typically people are given at least 10 or 15 minutes to complete the task. And as you can kind of see, if 10 minutes is 600 seconds, actually most of like 46 people were completing well in time, which is interesting again. But if we're kind of assuming actually that the kind of additional 3D perceptual cues that are introduced via the VR system, they're actually aiding people's ability to mentally rotate these shifts, which could be, again, responsible for both them doing better and them taking less time. Okay, so again, just to kind of re-summarize, we found these large sex differences, but we're kind of still skeptical about why we found these sex differences. So one thing that we've been also kind of thinking about are some other factors. So like, for example, one of those environmental factors that we think could be explaining part of the effect is this difference between the amount of experience, say, in video games between men and women that would have been coming into the experiment. So if I go back to here, some of you probably will recognize the HTC Vive controller. So it was run on HTC Vive. And I think it's probably pretty reasonable to assume actually that people that, if they had VR experience or they have video games experience, like even just navigating the kind of HTC Vive controller, you're probably going to be able to do that much easier if you've spent a lot of time playing Xbox or PlayStation or something like that. And so if you are kind of just so caught up and tripped up about, say, using the controller, then you're going to be kind of spending all these kind of cognitive resources on problems that aren't related to how well you're doing.
Yeah, I'm somewhat surprised that the experimental design is so challenging. I mean, clearly it's a very controversial result, and so you really have to be very thorough in divining whether you should even publish this or not, because if somebody hears about your experimental design, you're in big trouble. And clearly you're very focused on that. Have you tried kind of the contra situation where you've kind of leveled the playing field and then tried to work out what the differences are, or do you always see the difference? I'm just curious. Have you tried removing, like changing the problem so that it's not a rotation task, it's a translation task, so there is parity, and then subtly trying to gradate it at all, or not really? I'm just curious.
So this is my first experiment for mental rotation. There are literally thousands of manipulations, and they're extremely robust, the differences between men and women. And I would say it's not super controversial because nobody really thinks it, like people are curious about it because it's robust and it is easy to find the effect, but nobody really thinks it actually makes much difference in real life, or at least I don't think so. And it's kind of, people are much more interested about, okay, so what kind of sociocultural factors are going on that could be responsible for
That's what I'm
these
saying. Like, have you
results?
tried different cultural features?
No, but people have. And so, for example, like there are all these cross-cultural comparisons of mental rotations between people from different cultures. And they do find that these, again, like these differences are robust. They find them in all cultures throughout the world. But they do find them reduced in more gender equal countries. So places like the Nordic countries, they tend to have much smaller differences in mental rotation, but the effect still doesn't go away, and so it gets decreased, and it has been getting decreased over time as well as we move towards hopefully a more gender equal society. But there's still kind of all this unexplained variance, and people are, it's kind of this constant quest to explain that variance. What could be going on, and what else are we missing here?
Very interesting.
And kind of on that note as well, like one kind of interesting thing about it is, I say we're moving towards a more gender equal society, and in some ways we are, but in other ways there is still sort of this like bistratification of different sociocultural experiences, and so that, like, I think the video games is a good example, where it's like obviously video games have evolved a lot over the past 20 or 30 years. So, you know, if you look at people, say, in the early 1970s, they wouldn't have had this like video game experience, and they wouldn't have had that kind of socio-cultural effect that could be impacting the results. So that's what we're kind of interested in. So I don't get into questions around video game use or VR in this experiment, but I've followed up with the 46 participants to collect information on just how much VR experience they have and just how much video game experience they have, to hopefully do something like this again, where I can hopefully try to see, is that playing an influence. There's also this stuff around decision confidence. So this kind of gets back to what I was saying about how there's this evidence that there isn't actually a difference in ability. There's just this evidence in the evaluation of people's abilities. And so like one follow-up test, like experiment I'm going to be doing with another friend will be kind of around this, trying to get a measure of just how confident are people and seeing whether that is playing a role. And so that would be done through like things like a questionnaire, asking people to rate their confidence on each question. And then there's actually, it really is just like a huge area with so much potential. There's so many potential future directions for it. So again, it's like I like that kind of analogy I just mentioned about how it is kind of a quest to try to explain what's going on. And so there's all these other interesting side notes as well. So for example, like the mental rotation, one kind of big area of research in mental rotation has also been about how mental rotation abilities differ between different people with different sexual orientations. So a classic example is like gay men tend to perform like heterosexual women, and lesbian women tend to perform like heterosexual men. And so we're also currently just starting data collection for testing to see whether in VR we also find these differences emerge. It also will be a replication to see whether we're still finding the same gender difference in heterosexual people. There's also these questions around head tilt. So as Sam kind of mentioned, like one kind of theme that's kind of close to my heart is this idea of how can we use emerging technologies to improve both research and people's lives. And one cool thing about the VR aspect that we also don't get on pen and paper is we get all this additional kind of sensory information. So we get information about eye tracking. So the experiment was done with eye tracking and head tracking as well. And so there is all this research, for example, that's kind of interested around this idea of why do people tilt their head? So if you're like reading a book on a shelf, for example, like why would you tilt your head? And we see this in VR, and when we're doing a mental rotation task too, some people will rotate their heads. And so we're still in the data analysis phase of this, but we're kind of really interested in this question of like, depending on the difficulty of the question and looking at the performance, how does like head tilt play a role in that? So do people do better when they're tilting their head more? Do people just respond faster, for example? There is this kind of like these open-ended questions that we're hoping to be able to answer because we have this kind of unique access to this information that we wouldn't normally be able to collect with just pen and paper. And that's pretty much it. Questions?